Right. Session 4 on simulation frameworks for V2X. I would like now take the privilege to introduce Dr. Kiran Mannem, sir. Dr. Kiran Mannem, sir, is a professor in the Department of Electronics and Communication Engineering at GRIET, Hyderabad, with over 21 years of teaching and research experience. He holds a PhD degree in ECE from JNTU Anantapur and a postgraduate program in artificial intelligence and machine learning from Great Lakes Executive Learning. His research interests include wireless communication, VLSI design, AI/ML applications, and computer networks. Dr. Kiran sir has published 33 research papers in SCI and Scopus indexed journals and actively contributes to the lab modernization and academic coordination at GRIT. Sir is a fellow of IETE and IE and a senior member of IEEE. He has served as a resource person for national level FDPs, including ATAL programs on AI-enabled 6G technologies and for technical training sessions organized by Telangana State Police Academy. We welcome you, sir, to the session 4. Please continue, sir.
Thank you, madam. Thank you for our nice introduction.
So you can share the PPT, sir.
Yeah, I'll share it.
Yeah.
Can I see the PPT?
Yes, sir. Yes, sir. Press the slideshow, sir.
But I cannot see here.
Okay. Down, sir. Down.
Can you see the PPT? But
Yes,
I
sir.
cannot see here.
Yes, sir. Yes, sir.
You can see.
Okay, very good.
You proceed, sir. Not.
Yeah, I cannot see here. That's why I'm checking.
Yeah, you can proceed.
Anyway.
So you can proceed, sir. Not.
Yes, yes. Just and begin. So it's my pleasure to be the part of the ATAL FDP on V2X Beyond 5G Trends, Technologies and Future Directions organized by Vidyajyoti Institute of Technology. Today, I'll be speaking on simulation frameworks for V2X, focusing on the NS-3 environment. So we'll explore how simulation helps us understand and evaluate V2X communication scenarios, particularly how NS3 can be extended to model vehicle-to-everything communications, mobility, and network performance under 5G and beyond conditions. I'll begin with a brief overview of V2X concepts, then discuss the architecture and capabilities of the NS3, followed by examples of V2X.
PPT is not moving, sir.
Yes?
PPT is not moving.
Not moving?
First slide only.
Can you see second slide?
Yeah. Now it's okay.
Yeah. Thank you. Yeah. So today's agenda is it has two parts. Part A focuses on the fundamental and setup. We'll start with an introduction to V2X communication, mainly V2V and V2A, and discuss why simulation is critical for real-world deployment. Then we'll move to the environment setup, how to run NS-3 and Sumo on Windows using WSL, Ubuntu, and X Server for GUI visualization. After that, we'll install and test NS-3, run some sample network simulation, and similarly install and test Sumo to verify the traffic GUI. Once the environment is stable, we'll proceed to part B, where the integration of the Sumo with the traffic control interface will be done. Finally, we'll see some results, some example results on the Sumo and NS-3 configurations. So this is our agenda for today's session. So in between, I'll move to the laptop and I'll show you the execution of the files. So let me start the next slide and I will see how it works. Basically, what is V2X? V2X is vehicle to vehicle, vehicle to infrastructure, vehicle to pedestrian, vehicle to network. So importance is road safety, traffic efficiency and all. What is the need for simulation? The need for simulation is before deploying these systems in the real world, testing them physically is extremely expensive and risky. So imagine setting up 100 vehicles, roadside units, and cellular towers, not feasible for every experiment. So this is where simulation becomes essential. So using simulation tools like NS-3 and Sumo, we can test network protocols and algorithms safely. So we'll measure latency, throughput, of course, packet delivery ratio after executing the output of the NS-3. But in this discussion, we'll integrate only Sumo with Python, and then we'll see the GUI. So overview of the NS-3. It's a basically open source network simulator. It supports WANET, LTE, 5G, Wi-Fi, TCP/IP, and advanced modules. It's more extensible, and we can integrate Sumo and other tools with this NS-3. And if you look at the modules of the V2X for NS-3, we have IEEE 802, 11P, Wave, and LTE 2X. And of course, we have also mobility models, constant velocity, random waypoint, and Sumo traces. And we have propagation models and applications in NS-3 modules. So let us move on to the next slide. So to make the framework for V2X, I started with this WSL, Windows Subsystem for Linux. And then we installed Ubuntu on this Windows subsystem for Linux. Then we integrated Sumo and NS-3 in this WSL. So what it does, In most of the cases, we use Ubuntu directly, or dual boot, or we can directly install the Ubuntu software, and then we'll install NS-3, and we'll see there are some packages and all. But if you look at this WSL2, we can install our Ubuntu NS-3 Sumo and all on this Windows environment. So that's why I installed all these tools in the WSL2. Now, how to run these tools, we'll see one by one. It basically tells Linux distribution inside the window. So how to install? Once we install, we can see how it works. So to install this WSL2, go to the Windows features on and off, and enable virtual machines and Linux, Windows subsystem for Linux, and it will install the distribution. And then we need to update the WSL. Then it will install the Windows subsystem for Linux. So this slide indicates that how to install WSL2 in the Windows 10 or more. This is slide number 5. So how to check this whether the system is installed or not? So we can go with command like WSL version. It will show some version. So if you don't have that version, we need to update it. Search for valid Linux distribution online. You can use this WSL list online command to see which distribution is available for this WSL2. So I used Ubuntu 22.04 for this framework. So I installed 22.04 on Windows subsystem for Linux. So once you install this Ubuntu 22.04, we should restart it, and it will ask for a username and a password. You can enter into the Linux terminal within Windows. Now what we are doing, I'll show you how to install these commands and installation procedure. Let me share. So can you see the screen, please? Can you see this turn Windows features on or off? Anyone? Can you see this Windows features?
Yes, sir, but it is not visible properly.
Not visible. Maybe now not visible.
We screenshots are there, sir, but
Mhm. Well, now
they're not clear.
Kiran,
Sir,
share all screen, complete screen.
entire screen, sir.
Then I think you are able to see what you are displaying.
Sir, can you see now?
Yes, now is correct.
Can you see this, sir? Windows
Yes, now
features.
yes, correct.
Yes, yes. See, this is the first step to install this WSL. Here you can see there are. I have already installed it. You can see some virtual machine platform. It's already checked here, and then Windows subsystem for Linux. So we need to check these two folders and click OK. It will show the installation of the WSL. So after that, you can see some Windows PowerShell here. So here you can see WSL running on the Windows PowerShell. It will regenerate the key. Okay, fine. So it's running, and you can see this Ubuntu kernel. I have already installed it. I'll share these screenshots so that it's very easy to understand. See, this is the first slide. And then I downloaded the Windows subsystem for Linux 2.6.1. And then you can see some list of the distributions, Ubuntu distributions available for this WSL. Among these, I selected Ubuntu 22.04. That is Ubuntu 22.04. So then I installed this Ubuntu 22.04 using the command WSL -install the Ubuntu 22.04. Now, after 15 to 20 minutes, it was installed, and this command prompt is ready, Kiran at Vishnuasini. So it shows that Ubuntu 22.04 is available on WSL2. So to check this release, I used the command lsd release -a, and you can see release name is 22.04 and the code name is Jami, and distributed ID is Ubuntu. So that's how I installed this Ubuntu 22.04 on WSL2 version 2. Earlier it was WSL1, but this is the latest version WSL2 and the latest version of the Ubuntu 22.04. So let us come back for this slide. I think, can you see the slide now?
Yes, sir.
Okay, thank you. So after restarting, Ubuntu shown in the search. So I opened this Ubuntu earlier. So now it is the system is ready for execution of the programs. Now what we are doing, by default, WSL2 is a command line only. But if you look at the Sumo or NS-3, we need some GUI. So we must connect it to Windows X server, a small program that shows the Linux Windows on Windows. So we need to install this X server on Windows. So it's like a monitor for all your tools. So to install this X server, we can again go for this Ubuntu terminal, and we can launch this HTTP this download form, and you can see X launch wizard like this. So for getting your yeah. Yeah, this is the display settings for your X server. We need to select multiple windows, and then start no client, and then you can finish this setting. So I would like to launch this X server on my laptop to see all the examples. So I'm launching this X launch. Can you see this? And start to know client, and
Yes,
we
sir.
need to uncheck this and disable access control. So we are not giving any access control for this, and finish this setup. Now your XLAN setup is ready, and you can see here the right tray X. See here you can see 00-0 clients. So now your XLAN is ready on my laptop, and I'm also ready with Ubuntu on the WSL2. So till this point, we install WSL2, Ubuntu, and X server on Windows. Now configure Ubuntu inside WSL2. So we need to connect our server, X server, to our Ubuntu. So how do we do? Using this display variable. So if you export this display variable to the Ubuntu and sourcing this file, you can see the visual for your Ubuntu setup. So for this, I installed this. We already installed this. Let us check. I have already installed it. Let me show you the screenshots, how it works. So this is export display command. I installed it, and you can see some etc resolve configuration. And then you can see some X clock. X clock means it will show the display, the clock display. See after sourcing. See, there was a problem with this X clock. See, there was an error showing that 10.25.25.254. So that is with the IP address of the system. So here we should eliminate this error by permanently keeping the correct IP address in your server. So generally what happens, we have two IP addresses in our system. One is for wireless and one is for Ethernet. So if you take wireless, what happens if we move our system from one place to another, it will change. So what we do, we fix the IP address for this X clock. So for that, what we do, I open this resolve etc resolve config file, and I added this line, network generate resolve config it is equal to true. Earlier it was only systemmd is equal to true. So if you add this, what happens? It will identify the network of your system. So after modifying the configuration file, it will show some IP address 172.17.0.1 as each 0 proto kernel. So if you export this, what happens again? It is showing error. So what I did, I permanently resolved this problem by setting this, fixing this IP address with Ethernet IP. For this, I did some modifications in the system file. So here the shell file is ./bash rc, and I edited this bash.rc to find the solution. What I did, I added all these two lines, AutoSet display line in the bash rc. So what it says, we'll fix this host IP and export whatever you have in the Ethernet IP. And no need to manually check and or edit again. So if you keep these two lines in your bash HRC, you can easily fix this problem. So I fixed this problem by adding these two lines. See, it adapts automatically even if you switch routers, reboot, or anything. And then what we do, again, we should source our bash file in the Ubuntu terminal. Then only it will display the IP address. And also we'll see how it works. See, I typed X clock. It is showing some clock here. Can you see here? So it means it is working. So my server display is working with Ubuntu. So now I can show some visual programs to the server. Okay. So I'll stop this. So till now, what we did, we installed WSL to Ubuntu, and then yeah. So next one is installation procedure for NS-3. Now my system is ready with Ubuntu and X server. Now I want to install this NS3.45. So I tried NS3.46. There's an earlier latest version released in the last month, but I got some issues, and then I installed this NS3.45. To install this, we need to update dependencies in the system, in the Ubuntu system. So if you execute this, install all these libraries, and then we clone this, you will get one file from the clone, and we need to configure and build this file. So that's very important. While building this, it takes some time, but of course you may get some errors also. But if you get some errors, again we need to clean the configuration, and again we should rerun the NS-3 procedure. So for this, I'll show you how. So this is the adding lines, auto set display lines in the bash file. And then I sourcing the bash RC file to display, to get the display. And see, you can see these host IPs, which are same, 172.17.0.1. So now I come across this installing this NS-3 all in one, but I tried this latest version. I got some issues and I dropped this and I installed 3.45. So you'll get failed build the NS-3 environment like this. So we have 2000 packages, and out of 2000 packages you miss something. So I install this 3.45. Here you can see this is the NS-3 build here. Now, what are the modules available? This NS-3.45, you can see here point-to-point and tab bridge, WiMAX, virtual net device, and see the modules which are not built or installed visualizers, OpenFlow and Click MPI. Of course, we can install it later, but for now, I install only core modules in the 3.45. These are the modules available with NS-3.45. This 3.45 enable the examples and tests in the NS-3. Yeah. Coming back to our slides. Now, what's the background for this NS-3? Earlier, we have WAF building for the NS-3.35, but in modern NS or above 3.35, we have a .NS-3 build, which is wraps around CMake and Ninja. Earlier it was Python bindings and is the latest wrap bindings for these latest versions. So earlier we used .waf to execute our programs. Now we use .ns3 for executing our programs. That's the basic difference in the latest versions. Now, what's the directory structure for this 3.45? You can see several folders in the directory. So to understand NS 3.45, we should know all these folders. One folder is examples. This is the official tutorial and example programs, and Scratch folder. So if you want to execute your own simulations, you should place your code in the Scratch folder. And then SRC is the source code for NS3 modules. So we have source codes for all modules in this folder. So build means it's a compiled binaries. When we are executing modules, it will build the binaries. So all these binaries will be available with build. And then NS3, it's a script file to build our examples or our own code. And utils, it can see some visualizations and conversions. We'll see examples to learn the ready examples and Scratch folder for develop your own code. So let us check the first program .ns3 run examples in the tutorial. So let me show you this. So we need some commands, Linux commands to execute these programs. So I entered into the NS3.45. See, there are several folders inside the NS3.45. As I said, you can see a green colored NS3. So using this executable file, we run all our examples and own code. So now I'll move to this examples. You can see several examples inside your example folder. And go to the tutorials. See, you can see some first program, second, third, and you can see two bindings here, two codes. One is .cc file and .py file. So that is Python file and C++ file. Most of the every time we should write the code in either C++ or Python. So we'll execute the first program in this tutorial. So can we execute here itself? Anyone? Can I run this file here itself? The answer is no, because we don't have our NS3 executor here itself. So we should go to the NS3 folder again. Should remember these paths. So here we should execute .ns3. So where do we have examples? So this is the folder examples. In that tutorials, and I have in the tutorial first program. So we can keep here like this. So we got some error here. Let me check. Sorry, I forgot to run this. So we should type run here. Should run this example. I think I need to have this .cc here. See, I executed successfully my first program in the examples tutorial, and here you can see at a time 2 seconds. So client sent 1024 bytes to one of the client 10.1.1.2 at port number 9. That's the first line. Second line indicates at timestamp 2.00369 server received the 1000 bytes. So now the server received this from the 10.1.1 against the port 49153. Similarly, you can see server sent 1024 bytes to the 10.1.1.1 port 49153. The same port used, that is server received the bytes and sent the bytes. And then last client received the bytes. So this is a simple program, the connection between server and client, which has the IP addresses 10.1.1 and 10.1.2 using port number 9 and 49153. A simple example. execution of the NS-3 in our Ubuntu. Okay. So till this point, we executed our basic simulation in NS-3. So move on to the next slide. Suppose if you want to run own simulation, so we need to go for Scratch folder. I think I have shown this Scratch folder here itself. You can see by typing ls, you can see some Scratch here. Say this one, that is cd Scratch. So if you want to run some program, even if you copy first program to this folder, and you can run the simulation. So what's the difference? The difference is when you run any code inside the Scratch, it doesn't affect the modules of the NS 3.45. So if you want to change the modules, and you should add those modules to your program. So when you are executing example problems, it will not modify any modules already installed in your 3.45. So that is the basic difference between your code and already existing tutorials. So that's how we can run the own simulation. So this is the automatic compiles the Scratch on fly. If you want to modify the modules, you can modify it. So now moving on to this logging and tracing in NS-3. So what happened in our example, we can see some text messages about the simulation. So logging system means you can see some text messages on the terminal itself. Tracing system means you can record the network data like packet transfers and timestamps and all in the .pcap files or trace files. So again, we need some tools to visualize all these files. So we should add those tools, Wireshark or NetNM or any other tools to visualize all your output data. That's a challenge for this NS 3.45 or network simulators. So moving on to this 16th slide, SUMO. SUMO means it's a simulation of urban mobility. So we have network simulation in NS3. In V2X communication, we need to take the real-time data, real-time traffic from this SUMO, and this can be integrated. This can be sent to the NS3 to identify these outputs. So what's the difference? The difference is basically NS3 gives the network simulation and SUMO gives the mobility patterns, real-time mobility pattern. So if we can visualize this traffic scenario via X server, we already installed this X server, and we can visualize that using this SUMO GUI. So now how to install this SUMO? So again, we have a few commands to install the SUMO. Of course, it was shown here, install SUMO tools, SUMO doc, and we need to test whether this SUMO is working or not. The condition is your server must be running. That is, we already kept the server in running, and you can see that in the tray. So if you have that running the server, you can see the GUI. Otherwise, you cannot see this GUI in the system. So that's why we install GUI in the first after installing the Ubuntu. I'll show you how to install this Sumo. See, you can see this sudo add apt repository from the stable version. And I updated this Ubuntu for a few packages. Of course, all packages are up to date. And see, sudo apt install sumo tools and sumo doc. So while giving this command, you can see some continue or no. So press yes to install this sumo. See, after installing, you can see this sumo my GUI. So let me show you that GUI. Yeah. So I'll come back. So I can see here folders here, sumo. So I think you can see this sumo 1.24.0. See, is the GUI for sumo. So this was shown in the screen itself. I close this. So now we installed sumo in our terminal, Ubuntu. Now again, let us look at the sumo's directory. Where do you find all these directories in our system? So this is the biggest challenge in our Ubuntu system. We should know all the files and folders in your tools. So let us find out all these folders and what it does. So if you look at the sumo directory, you can see some core folder at root, user, share, and sumo. And it's like your shell type in your Ubuntu. So and you can find these sumo tools helpers in the user bin, and we can even see some examples in sumo doc and examples. So let us look at all these directories in our Ubuntu system. See, I can see only NS 3.45 and see some sumo integration and sumo projects. Can I see any sumo here? No. So what happened? You can see all these files in the root folder. So if you want to go to the root folder, type \. So if you want to see the path, you can type pwd. You can see the path here. So now we are at root of your Ubuntu system. Let us check the files here. Files and folders. You can see some user here. So you can go to this user. So your sumo installed on the user. If you look at the user, again, you can see some share here. See, there are several files in the user share, and you can see some sumo here, and also this is your sumo folder. Here it is. Let us move on to the dark folder. So here you can see some sumo dark here. And in this, you can see some examples, right? See, in earlier versions, these examples were kept in the first folder, user folder itself, but in the latest version, these examples, system examples are kept in the Sumo doc. So you can see some examples here. Sorry. So you can have some JRouter, net converter, run all by Sumo tools in the examples. So we can see your tools here. So this one, this converter, durator, earlier it was in bin, and now it was moved to the examples. Now if you look at these tutorials, let us see the tutorial. See, these are the tutorials for the Sumo, circles, hello, public transport, quick start. These are all inbuilt example for Sumo. Let us check the folder. Hello. You can see some files. See data, net.xml, runner.py, test.batch, test.sh. So what are these files in the example? Let us have a look at our PPT. See, these are the contents of any example. See, the data means it contains network, routes, and configuration. And if it's like, check out this runner.py, it's a Python script to launch the Sumo simulation. And .xml, it will give the output of the data. And coming to this test.bat, it is the Windows batch file. And test.sh, it is for Linux shell script. So we are using Linux shell script. We should use this test.sh for executing this tutorial. So let us talk about detail data folder. See, you have some .xml files inside your data. So which defines networks, routes, simulation configurations, and if you want, you can add some extra definitions, traffic lights, detectors, and all. And even you can open this using .sumo cfg configuration file using Sumo GUI. And if you look at this runner.py, it's a Python script, and you can even see traffic control interface Of course, we integrate later. After this, we'll see how to integrate the Sumo with our Python script. Of course, test bat and test research. Okay. So let us run this example. See, can I run my tutorial here itself? The answer is no, because if you run your tutorials here itself, you'll get some errors, because you don't have any permissions for all these files. So that's why what I did, I created a separate folder to test our examples. So we'll come back to the home folder. And see, has some folder NS 3.45, NS-3 Sumo integration and Sumo projects. So I created this folder, Sumo projects. Yeah. So now I copied the hello program, hello and public transport programs here itself. So if you execute these programs here itself, we don't have any issues with the core modules. So that's why I separately executed all these files. So అంతే సార్ అయిపోయింది సార్ 2 examples. Alright. So let me show you this example. See the same for files here, data .xml .py, and so since so what is the command to execute this? So this is the command bash test.sh for our Linux. So let us execute this bash. See, it opened GUI. I am putting it is 100. Let me make 200 so that you can visualize this screen here. I'm executing. Yeah, you can see one vehicle moving on this road. See, there is an arrow mark going on the road. The simple example, hello. So I can show you one more example here itself. Go to the public transport. Again, bash. You can see ls here. See, this is the public transport. Here you can see, I'll put some delay here. It is 0. I'll put some 100 milliseconds so that you can visualize this real-time traffic and run here. You can see there are 2 trains moving in opposite directions, and one vehicle is moving right side. So this is about Sumo integration with NS-3, and now this data can be integrated or sent to the NS-3, and we need some integration for that. So I'll quickly close this one. So I think with that, I completed integration part. Now what happens during integration with the Python or NS-3, Sumo runs the scenario and it will act as a server, and it will open the port 9999 and it will send the script to the traffic control client using 9999. And this is the integration part. I'll quickly show that integration also. So this is the installation and the Python modules for this. I'll show you quickly this one also, integration part. So for integration part again, I'll go to this. I can see the folder named as integration. So again, you can see here the NS3 sumo.tracy.py. I installed already this one. I made it as executable. So we can run this program. So to run this, we use this Python NS3 sumo dot this one, this command. So earlier I made it, I gave some permissions and I created some workflow for this. Python 3. See, there is a vehicle moving from left to right. There is a first program, hello program. There is one vehicle from one end to another end. And if you look at this output, we can see some. So the output means the first line starting Sumo GUI, that is our Python script successfully launched via some real-time traffic folder. And then retrying in 1 second means connection refused, and it takes 1 second to execute this command, and then connected to this traffic control interface. So likewise, you can see some vehicle moving from one end to another end. You can see here the output with some steps. So in the program, it was given 50 steps. So for each step, you can see the vehicle location, the position of the vehicle, and this data. This data will be transferred to the NS3 module. So this is the live data given to the NS3, and that data will be taken as nodes for the network simulation. And later, it can be validated via metrics like PDR and latency. So this is about few examples. So with this, I'll close this integration part. So coming to this, what are the tasks taken till now? We installed WSL, Ubuntu, and X server, NS3, Sumo, and Sumo with Python with traffic controller, right? So we have successfully built an integrated V2X simulation environment on Windows using all these WSL, Ubuntu, Sumo, NS3, and Python. So what are the remaining leftovers till we can do Sumo with NS3 coupling? That is the mobility updates in NS3. That is the data which is coming from the Sumo. We should add it here, and then we can even see uh, networks, adding the networks to your modules and simulation scenarios, and then we can do some performance analysis like NS3 tracing file and using some NetNM or PyVis or X server. So these are the remaining topics. Maybe you can try all these after installing these completed tasks. So the conclusion part. So in this session, we successfully demonstrated the setup of complete V2X simulation environment using the tools like Ubuntu server, and we verified Sumo mobility control through traffic control interface and established foundation for real-time integration with NS3. And the next phase, so we can focus this coupling traffic with NS3 communication models to simulate V2V or V2I interfaces. And this framework will enable comprehensive analysis for vehicular communication. So I think with this, I completed my session. Now, what are the advantages and limitations? Advantage, it's an open source. If, anyone can write the code and we can upload, or we can send this to our NS3 for verification. And limitations requires C++ or Python code, and we need some steep learning curve. So it's a complex for large urban scenarios. And I took all these from the NS3 official website and some tutorials on GitHub repositories. So thank you for patient listening. So if you have any questions, you can ask.
Audience, any queries? So check it in the chat box, sir.
Yeah, let's check, sir.
Yeah. Audience, any queries?
I think no queries. Is there a Windows platform supported NS3 Sumo simulation, urban mobility software, or is it available for the Linux version only through WSL for Windows? Is the software open source? Yes, uh, we have one more. We have the Windows environment directly from the NS3 module, but it has older versions. It support all the latest versions in the Windows itself. Better use WSL. It's a latest version. It will be integrated with our latest NS 3.45 and so on. Is the software open source? NS3 is open source, but WSL it is inside the Windows. So Windows obviously proprietary. Any authenticated link available to learn NS3 SIM software via Twitter? Yes. Already I have shown you the link NSAM. So we can directly go check the NSNAM site, and you can see more tutorials and also apps, app stores, and downloads. Everything is available in the official NS-3 site. So that is the first query. Next one is please send link. Yes.
Adu okay, sir. Adu okay. Adu
Huh?
okay.
Yeah,
That link.
I'll send.
Yeah.
Next one is the Windows platform supported. Sumo simulation. Yes. Sumo simulation can be done with in Windows as well as Linux. I installed the Linux version, and you can see some batch file. That batch file for Windows. Is the software open source? Yes, you can directly download Sumo software from the Git repositories. Any authenticated link? I think SIM software.
Yeah.
It is there already. I'm unable to see a link of second half. Okay. Here the vehicle interconnection is shown. What about sensor interconnection with vehicle and process? And can we control based on program? Yes. So we can create our own script in the Sumo coding. So that code can be integrated with your NS3, and we can send the live data, live traffic data to the NS3 module. So using your Google Maps, you can directly uh, send the live data to the NS3. So that's why we use Sumo for live mobility patterns. Any more queries? I think,
Audience, any other queries?
thank you for clarifying doubts. This topic to students. Yes, you can definitely introduce this topic to our students. They can learn easily. So I can share my PPT to the organizers. You can use that for installing all these tools. And I think I have shown the leftover topics and completed tasks. You can complete those tasks, and you can have a complete V2X simulation environment using NS3.
Audience, any other
Yes,
queries?
definitely I'll share my PPT. Any more?
Shirisha, madam, you can conclude.
Yes, sir. Thank you, Dr. Kiran Mannem, sir, for your valuable insights, knowledge, and expertise with us on NS3. Your session has truly enlightened us, sir. We thank all the participants for your active engagement throughout the session. Thank you all.
So thank you, sir.
Thank you all. Thank you for patient listening. So I sometimes
Thank you.
listen my
Feedback link you can find in the
voice.
chat box.
Shared, madam,
Sorry
shared.
for that. Thank you all.
Thank you, sir.
Yes, sir. Thank you very much.
Thank you, sir.
So I'll send this PPT